So obviously these disorders reduce eating quality, and they can include flesh browning, rubbery or dry flesh texture, abnormal ripening where the fruit won't ripen and remains hard even after long-term storage, and a marketing period, and tend to have low juice. So not very good in terms of eating quality. And they usually are very highly cultivar dependent. Many current cultivars are susceptible, and breeding programs don't generally test for storage performance, general storage performance, or look at storage disorders, which is an issue at the moment. And the standard practice is obviously to cool fruit down to 0 to 2 or 1 to 2 degrees up immediately after harvest, which is standard practice in the industry. And we've found that through some of Glenn Hale's work and some of our temperature monitoring work, that obviously for disinfestation purposes, you need a minimum of 21 days at below 3 degrees. But we've found over recent years that shipping can take 25 to 35 days. Sea freight of that length is going to cause problems, because most cultivars that we export, that's beyond their storage potential, to put it bluntly. So can we do something about the likelihood of these storage disorders occurring? Well, we looked at stepwise cooling after harvest. So this is just demonstrating the kind of experiment that we did to determine if initial cooling to a higher temperature could reduce storage disorders. So just going through this quickly, we did this for Majestic Pearl, Nectarine, and Polar Queen peach, white flesh peach. I'll just show you some findings for Majestic Pearl. So we monitored harvest maturity using a DA meter, and then at commercial harvest, obviously went in and harvested a large quantity of fruit, DA'd each fruit to determine the harvest maturity, and only selected fruits within that commercial range, which was about 75% of the total fruit. And this is early fruit, so we would consider unripe, and this is overripe fruit. And this is a common distribution of maturity from a commercial harvest. So 75% fruit was in that maturity band we were looking for. And then we segregated the fruit and cooled it to either 2 degrees as normal commercial practice, cooled it to 12 degrees or 18 over 48 hours, sorted it into trays, 2 degree stepwise cooling, 12 degrees and 18 degrees, assigned it to cool rooms, and then weekly removals. So basically they were taken out every week and looked at, or samples were, so 0 days shelf life. And then we also had samples that we stored at 18 degrees for 3 days and 5 days. Now, all the fruit in these free treatments was preconditioned to the preconditioning temperature within 7 hours of the commencement of cooling. The treatment was 48 hours, which included both cooling to these temperatures and then leaving the fruit at these temperatures for a total of 48 hours. And among each one of these temperatures, all the fruit was the same maturity, which was really important in terms of getting a good result from the trial. Because other trials, previous trials, haven't accounted for differences in the fruit maturity within these temperatures, which sort of confounds the results. It makes it difficult to find what's going on, or to determine what's going on. And this is an example of what we saw from Majestic Pearl. This is storage for 6 weeks at 2 degrees, plus ripening for 3 days and 5 days. And this is the preconditioning temperature, so 2 degrees, 12 degrees, and 18 degrees. And I've circled the chill injury we noticed for this particular batch of fruit. And as you can see, at both ripening periods, the incidence and also the severity of flesh browning and chill injury is significantly higher in the 2 degree fruit that was immediately cooled. So this is standard commercial practice versus cooling to 12 degrees and 18 degrees. I mean, we did find differences in some cases between the 12-degree and the 18-degree fruit. The 18 degrees was a little bit better, but 12 degrees, cooling to 12 degrees worked quite well. And I'll show you a figure here where we see the results a bit more scientifically. So we didn't see any flesh browning until 28 days into the storage period at 2 degrees. And these are the ripening periods. So straight out of storage, after 3 days ripening and 5 days ripening. And as the dotted bars are what's standard practice, cooling to 2 degrees. And this is 12 degrees and 18 degrees. And this is the flesh browning incidence in the fruit we looked at. And as you can see, there's significant reductions in flesh browning as you go along storage period of 35 days and then 42 days. You get a significant reduction in flesh browning incidence. So it was a really good result. And what was even better is we didn't find a lot of difference in flesh firmness among these fruit from undergoing different preconditioning treatments. So storing the fruit at higher temperatures early on doesn't really impact on flesh firmness, which is really good to see. And again, this information is on the HIN website in more detail if you're interested. So it was a really good result. And after 35 days storage, which is 42 days is asking a lot of any cultivar, but 35 days, which is 5 weeks, you see that there's no difference between the 12 and 18 degree treatment. They both work just as well. At this stage, we're recommending for commercial practice that growers cool their fruit down to 12 degrees, 10 to 12 degrees for 48 hours rather than 18. We're not sure how, at that high temperature, how that's going to impact on subsequent flesh softening. So now, in terms of potentially using this stepwise cooling technique commercially, what we're suggesting is for domestic, if you want to use it for domestic or sea freight export, this is the process. I'm quickly going to go through it. So basically, you've got a stepwise cooling period for 48 hours after harvest. And then you can, if you're packing immediately, you just go through the process packing, cool the fruit down to 0 to 2 degrees until ready for transport. On the other hand, if you conduct the preconditioning, stepwise cooling, 10 to 18 degrees, and then delay the packing, leave the fruit, cool the fruit to 2 degrees, and then, pack the fruit, and then you go back to this step, you pack it, and then standard process, cooling, and then transport at less than 4 degrees. On the right-hand side, though, this is something we've suggested. If you can precondition or stepwise cool, immediately pack, and then if it's going for air freight export, you cool the fruit down to 10 degrees on the pallets and then transport it at 10 degrees and then send it off for fumigation as required for air freight. Now, that's a high risk process, but the advantage is that the fumigator doesn't need to warm the fruit from 2 degrees to 18. They can start at 12 to 18. So it's a quicker process here, fumigate, and then cool the fruit down to 2 degrees. Now, I'm not suggesting you try this next season, but it's an idea for air freighted fruit. So to finish off, outcomes. So from the service supply chain project, we've demonstrated, firstly, that these air and sea freight simulation trials, export simulation trials, can inform cultivar storage potential. I mean, they can be used, these trials can be used to give us a really good handle on export cultivars and the storage potential and even, as you've seen through the models, shelf life potential. And we're able to conduct these trials under commercial and export conditions. Stepwise cooling, we've determined that it appears at the moment to significantly reduce potential storage disorders. in the cultivars we've looked at, and we expect the same result for other cultivars. And it could be an important process that can be implemented by the grower to reduce that potential, particularly for sea freight export. Then we've looked at the real impact on quality as a result of different temperatures and storage durations, and they can be understood using these storage and shelf life models and these calculators. But saying all that, good temperature management obviously is very important, but the temperature impacts on quality depend on the cultivar. At the end of the day, depend on cultivar and the storage period. Okay, so we've got to remember that temperature, the same temperature can impact a cultivar differently depending on what that cultivar is, its genetics, and the storage period. And also we've found that more temperature monitoring is required, especially from harvest through to the freight forwarder for export, and then beyond export, so during importer storage and retail. Thank you very much for your time.